Welcome to our video on Desktop Learning Module 2, Fluidized Bed. The setup includes a base unit and a detachable fluidized bed module. The base unit is battery operated and contains a water reservoir, pump, and control knob for adjusting water velocity. A display shows water velocity and pressure drop. Water is pumped from the reservoir upward through the fluidized bed and then returns to the reservoir. As velocity is increased using the control knob, the bed height initially remains constant while the pressure drop increases. The reason why the bed height does not increase up to a certain fluid velocity is because the downward acting weight of the particles outweighs the combined upward effects of drag and buoyant forces. As a result, particle-particle contact is maintained, the void fraction does not increase, and the fluid is forced to pass only through the existing void spaces. As the fluid flows through these voids, friction between the fluid and stationary particles causes energy loss, which appears as a pressure drop measured by the pressure sensor. In this region, the pressure drop increases almost linearly with fluid velocity. Beyond a certain velocity, a sudden decrease in pressure drop is expected as the upward drag becomes comparable to the particle weight, allowing particles to loosen and rearrange. The increase in void space reduces flow resistance, leading to a lower pressure drop. This continues until the pressure drop becomes constant and the particles are fully fluidized. The lowest velocity at which this occurs is called the minimum fluidization velocity. In the demonstration, bed height remains constant up to 1.35 liter per minute, indicating minimum fluidization velocity. Beyond this, bed expansion occurs. At the same time, pressure drop becomes nearly constant with small fluctuations due to particle motion and sensor limitations. Above minimum fluidization velocity, pressure drop remains constant as upward forces balance particle weight. Additional velocity causes bed expansion rather than increased pressure loss because the particles are already fluidized. During the demonstration, the transition proceeds without any sudden pressure drop. Instead, pressure drop is stabilized at about 0.4 millibar. This is due to gradual fluidization, particle size, density variations, and wall effects in the small column that nullifies the decrease in pressure drop. Limited sensor resolution was responsible. Fluidized beds are widely used due to excellent heat and mass transfer, with applications in power generation, pharmaceuticals, food processing, environmental systems, and many more. Regarding safety, secure mounting and leak-free connections must be ensured. The module should be operated within the specified flow range to prevent carryover. Hands must be kept away from the module during operation, and the pump must be switched off before any adjustments. Proper lab attire must also be worn at all times.